When it comes to truck engines, the turbo is like the behind-the-scenes hero, making sure these road giants have the power and efficiency they need to travel thousands of miles. But how does a turbo actually work? And what sets it apart from a car turbo? Today, we're going to dive into the fascinating world of turbochargers to uncover the secrets and workings of truck turbos. The truck engine, the origin of the turbo. To understand how a turbo improves performance, we first need to know how a truck engine works. It all starts when the engine draws in air through its air filter. This air, full of oxygen, enters the engine and is compressed by the piston as it rises inside the cylinder, which increases both the pressure and the temperature. It's like a giant air pump that makes the whole combustion process more efficient. Once the air is compressed, diesel fuel is injected directly into this pressurized air. Unlike gasoline engines, which use spark plugs to ignite the fuel, in diesel engines the compression of the air itself generates enough heat to start combustion spontaneously. This collision of air and diesel creates small controlled explosions that push the piston downward. This push converts the piston's linear movement into rotation, activating the crankshaft and generating power. After this phase, the exhaust valve opens, the piston rises again, and expels the leftover gases outside. But this is where the turbo comes into play. How does the turbo come into play? The turbocharger is a crucial component that uses the engine's exhaust gases to drive a turbine, which in turn forces more air into the combustion chamber. This process not only increases the engine's power, but also improves efficiency by allowing the engine to burn more fuel. As this cycle repeats in each cylinder, the engine produces a steady amount of power, ensuring that the truck can keep going over long distances without losing strength. The history of the turbo. When did all of this begin? The turbocharger, or simply turbo, was invented in the early 20th century by the Swiss engineer Alfred Büchi. His work began in 1910, and by the early 1900s he had already patented his design. However, the idea of using turbos didn't become popular until the 1920s and 1930s, mainly in aviation. During World War II, fighter planes started using turbochargers to improve performance at high altitudes, where the air is thinner and non-turbo engines would lose power. This technology quickly spread to the automotive industry, and by the end of the 20th century, turbos had become a standard component for improving engine efficiency without sacrificing power. The world of trucks. The first model to feature a turbocharger was the MMK-26, launched in 1951. By the 1960s, turbos started to become common in heavy trucks, especially in Europe and North America. Today, it's not unusual to see that all large trucks use turbos, since they are essential for improving fuel efficiency and reducing emissions while increasing power. Types of turbos. Not all of them are the same. Turbochargers are not all the same, and each type has its own specific features to meet the needs of different vehicles. Here's a quick guide to help you understand the most common ones. Single turbo. This is the most basic turbo used in small and medium-sized engines. It's affordable, easy to maintain, and reliable, but it doesn't provide a big boost in power. Twin turbo. As the name suggests, It uses two turbos for larger engines like V6, V8, or V12. This improves power and torque, allowing the engine to respond faster. Twin-scroll turbo. This version has two separate exhaust chambers to improve gas flow. It's ideal for large engines that require better performance and efficiency, and it also helps reduce turbo lag or delay. Variable geometry turbo. This type adjusts the angle of the turbine depending on the engine speed and demand, which improves turbo response under different driving conditions. Electric turbo. Although still in development, this turbo uses an electric motor to spin the turbine, almost completely eliminating turbo lag. Although it's not common yet, it promises to revolutionize turbo technology. For heavy trucks, the variable geometry turbo is the most commonly used. It offers a good balance of power, efficiency, and reliability, and is ideal for large engines that require continuous and long-lasting performance. The turbo in a car versus the one in a truck. Key differences. At first glance, you might think that a car turbo and a truck turbo are pretty much the same. However, the differences are clear. Car turbos are designed for smaller engines, aiming to maximize efficiency and moderate power. They are compact, cost-effective, and don't require a complex cooling system. Truck turbos, on the other hand, are much larger, built to handle high-load diesel engines that need constant power over long distances. In addition, they feature advanced cooling systems to keep them operating at optimal temperatures and, generally, are more expensive due to their robust design and the demands of heavy-duty work. In summary, both types of turbos serve the same purpose, to improve engine power through forced induction, but they are optimized for very different needs. Disadvantages of turbos. What you need to keep in mind. Like any mechanical part, turbochargers have their downsides. Although they offer many benefits, they can also be prone to failure if not properly maintained. The most common causes of turbo problems include lack of lubrication. The turbo needs a constant flow of oil to function properly. A lack of oil can cause irreversible damage. Damage from foreign objects. Any foreign particle that enters the turbo can damage the turbine blades. Overspeed. If the turbo is subjected to excessive stress, it can exceed its limits and fail. Oil contamination. Dirty oil can damage the internal components of the turbo. Excessive heat. Excessive heat can wear out turbo components more quickly. That's why regular maintenance is essential. Changing the oil at the right intervals and using high-quality oil are important preventive measures to avoid serious problems. And in the event of a catastrophic failure, metal fragments can enter the engine and cause significant damage. Is it possible to upgrade a truck's turbo? Yes, and in fact, many drivers and transport companies optimize their turbos to get more power, better fuel efficiency, and higher performance. This is achieved by making adjustments to the ECM, electronic control module, which modifies the air-fuel ratio, turbo pressure, and other engine parameters. By making these modifications, you can gain benefits such as increased power and torque, better fuel economy, reduced turbo lag, and improved engine response. However, these adjustments should be carried out by experienced professionals and must comply with environmental and safety regulations. Impact of the turbo on performance and fuel savings. The use of turbochargers in trucks has completely transformed the transportation industry. Thanks to turbos, trucks can generate more power without the need for larger engines, which not only improves on-road performance but also reduces fuel consumption. This translates into long-term savings, especially in an industry where fuel costs are one of the biggest operating expenses. Turbos have also allowed fleets to use smaller, yet equally powerful engines, which improves fuel efficiency and reduces emissions. This is one of the main reasons why modern trucks can operate more sustainably and economically. Don't forget to subscribe for more content about these giants of the road.